Hello, my name is Brian Tarbox. I teach the Phage course at Southern Maine Community College. My Phage students this year are Clay Liu, Maria Rosales, Kaya Watkins, and Jillian Williams. Clay may not be with us in real time as he lives in China, but we hope he'll be able to watch the recorded proceedings. The Southern Maine Community College has a campus on Casco Bay, the Gulf of Maine, in South Portland, Maine. We have a marine science program, so we're interested in marine phage. Last year, we isolated a yellow pigmented gram-positive rod-shaped bacterium from marine mud. Sequencing of a portion of the 16S ribosomal RNA gene indicated that it's in the genus Microbacterium. It's denoted on the C. phage's list of hosts as Microbacterium species Casco Bay. Although we were able to grow this bug in the PYCA medium normally used for terrestrial microbacterium, it grows better in a high salt, low nutrient medium. Most marine bacteria are gram-negative, and we assume that most marine phage infect gram-negative hosts. So it took us a while to find some phage that infect our new gram-positive host. We finally found one, Gardoir, from a biofilm on a marine sponge. We also isolated a terrestrial phage, seawolves, that infects Microbacterium foliorum. Seawolves was isolated from garden soil on campus. So here's a view of Casco Bay from our dining columns. We can't see any phage in this picture, but we know they're out there. So the object of our research this semester has been to compare the terrestrial and the marine phage. We have not had access to the lab due to another virus, so have not done any host range studies as yet. The TEM images here indicate that both phage are Cyphoviridae. The plaque images show that the seawolves on the left yields a typical lytic plaque. This makes sense as all the Microbacterium phage discovered so far seem to be lytic. The plaques for Gardoir, however, show a turbid halo and resemble temperate plaques. A temperate life cycle would be unusual for cluster EE phage, although not for marine phage. So this is a Famarator map comparing the genomes of Gardoir and seawolves. They both show a high degree of homology to each other and to other cluster EE phage. This map was done with draft genomes, so the frame shift in gene 10 hasn't been called yet. There's an interesting sequence in gene 10 in Gardoir, however, which we'll come back to. Our goal was to compare the two genomes to see if there is anything unique about Gardoir which allows it to exist in a marine environment and whether it can adopt a lysogenic life cycle. So we aligned both genomes looking for single nucleotide substitutions. We found 52 substitutions between the two genomes. 40% of them are transversions. Though most of these were neutral changes, 8 of them lead to amino acid substitutions in GPs 4, 15, 16, 18, 19, and 23, thus potentially leading to a difference in phenotypes. So notice the difference in genome length towards the middle of the slide, however. Gardoir's genome is 34 base pairs longer than seawolves. This is due to a 1 base pair gap in the seawolves gene 4 and a 33 base pair repeat in Gardoir's gene 10, the tail assembly chaperone. You can see the repeat motif here down towards the bottom of the page. This repeat is located 26 base pairs upstream of the slippery sequence. The alignment of gene product 10 here shows the amino acid sequence of the repeat. We don't have any evidence about how this repeat might affect the phenotype. Repeat is highlighted in yellow. We're also interested in whether Gardoir can form a lysogen with its host. Again, this would be highly unusual for a cluster EE phage, but we know from other research that many marine hosts can be lysogens, especially in the cold months in temperate waters. Our evidence so far is the turbid appearance of the plaques. Kaya has also investigated genes 20 and 21. These are the first two of the reverse transcribed genes, and HH-PRED showed some evidence that they might have repressor function. We have not found any other genes related to lysogeny or evidence of an ATP site. We'd welcome any advice on pursuing this. So in summary, this is as far as we've gotten. We have a marine host and a marine phage. We know the host can be grown in both low and high salt concentrations. We don't know as yet if the phage will infect both hosts at both high and low salt concentrations. We do see genomic differences between the two phage, including an interesting repeat in the tail assembly chaperone. There may be some evidence for lysogeny. So we're hopeful we'll be back in the lab this coming fall. Our goals are to explore host specificity and salinity tolerance for both Gardoir and seawolves, investigate whether Gardoir is indeed temperate with a patch test, and look for new marine phage that infect Microbacterium Casco Bay. Here's our literature cited. We'd like to acknowledge and thank the people at HHMI and UPIT for providing the great support for the C. phages program and for providing really meaningful research for undergraduate students. We'd especially like to thank Deborah Jacobs-Serra and Daniel Russell for helping us with our new host. We also received some financial support from NSF IMBRI grant. Finally, thank you to all the members of our poster pack for their comments and advice. We look forward to discussing your posters as well.